Welcome back. In this session, we'll try to discuss about Nmap port scanning. The basic objective of Nmap port scanning is Nmap command structure, and second should know that host discovery, how Nmap scanning works for port scanning, and how to find the target port scanning and identify the ports on target side. Then to do this, Nmap scanning, what are the different types of the Nmap scanning? Is the TCP scanning and UDP scanning that we'll discuss, and the scan status, whether they are open, closed, or filtered, or open filtered, or unfiltered, that we'll try to discuss. Then the scan time means how slow the scan process and how to make that process as fast, so that is scan timing settings and the output formats. And then we'll try to discuss the Nmap script engine and service detection, OS detection, timeout, and host delays. So these are few things in this particular Nmap port scanning series. We'll try to discuss this one. So what is a port scanning? So ports are simply a software abstraction used to distinguish between communication channels, similar to the way the IP addresses are used to identify machines on networks. Ports identify specific applications in use on a single machine, which we have seen in the previous lecture, that port number 20, port number 21, port number 22, port number 21, 22 used for the FTP servers, port number 23 may be used for your SSL server, and something like that. So all of these elements are simply numbers placed in the headers of each packet sent between hosts. So the protocol is an 8-bit field. The TCP protocol is having 8-bit field in generally. Okay, and you know for example, how to identify the applications. Your web browser will be default connect to the TCP port 80 of machine in HTTP URLs. But if you specify the secure HTTPS protocol instead, the browser will try port 443 by default. So Nmap works with two protocols that use ports TCP and UDP ports. So a connection for each protocol is uniquely identified by the four elements like source and destination IP addresses and corresponding source and destination port numbers. Right? So in this, we'll try to talk about, as said, the connection for each protocol is uniquely identified by the source and destination port numbers. So all of these elements are simply numbers placed in the header of each packet sent between the host. So what is port scanning means? Port scanning is the act of remotely testing numerous ports to determine what state they are in. The most interesting state is usually open, meaning that an application is listening and accepting connections on the port. So many techniques are available for conducting such a scan. So while many port scanners have traditionally lumped all ports into the open or closed states. Okay, but the port scanning, in the ports scanning phase, as we know that The number of ports field is your 16 bits actually. So there are so that 16-bit wide will give you the values range between your range that reach to 65,535 ports. So the lowest possible value is 0 is invalid. So the Berkeley sockets, the API, which defines how programs are usually written for network communication, does not allow port 0 to be used as such. So instead, it interprets a port 0 request as a wildcard, meaning that the programmer does not care which is used. So the system then chooses an available port number, right? So while port 0 is invalid, nothing stops someone from specifying it in the header field. So some malicious Trojan backdoors listen on port 0 of compromised systems as a stealthy way to offer illegitimate access without appearing on most port scans, right? So the ports can be either transmission control protocol ports or user datagram control uh, protocol ports. So depending on the service which is utilized, the port or the nature of your communication, like whether using the remote connection or whether you are trying to check the vulnerabilities in the domain name system or the dynamic host configuration protocol, that depends. So, what is the process? So, we'll try to check some of the Nmap basics. The Nmap basics. So, in this, for a single target, suppose if there is a single target system is there, then you require a single IP address. And by using that IP address, you need to mention the particular port number. So if we have a pen tester and there is a single target here, so the IP address which is given as 5.6.7.8, suppose for example, then along with to communicate to scan the port on this particular target, one needs to give the port number along with the IP address to scan on the target. So on this particular IP address, pen testers wants to check whether port number, what is the status of your port number 22. So to do that, there are different types of scans are there. That scan type is there: TCP scan, UDP scan. In TCP, you'll find the full TCP scan and half TCP scan, and the scan timings and outputs that we are going to discuss about this, right? So in this, in response to this particular request, the sign request from your pen tester, you may get the responses whether the port is open, closed, filtered, unfiltered, or open or filtered, or close or filtered. So the you will get these six different responses from the target side. So in these six different responses, when conducting a port scan, the Nmap tool will create a packet and send it to each designated port, like from port number 1 to 65,000, 536 ports, as we just discussed, right? So the goal is to determine what kind of response we get from the target ports. So different types of port scans can produce different results, but it is important to understand the type of scan you are running as well as the expected output of that particular scan. So the Nmap divides the port's responses into six states, and that is open, closed, filtered, unfiltered, open or filtered, or closed or filtered. That is the confusion states. So in the open state, an application is actively application means on target side, the application is actively accepting TCP connections or UDP packets on this port. So finding these is often the primary goal of port scanning. So, security minded people know that each open port is an avenue for attack. So, attackers and pen testers want to exploit the open ports while administrators trying to close or protect them with firewalls without thwarting legitimate users, without threatening the legitimate users. So that happens in this open port. So open ports are also interesting for non-security scans because they show services available for use on the network. So before you get too excited about an open port, note that it is possible that the application is protected with a TCP wrapper, we call TCPD, or that the application itself is configured to only service approved only the service approved client IP addresses, such as still leave more attack surface than a closed port. So another port state is closed port. So a closed port is accessible, means it receives and responds to Nmap probe packets, but there is no application listening on this particular port. So they can be the helpful in showing that a host is online and using an IP address that is in your host discovery or ping scanning, and as part of your OS detection. So because closed ports are reachable, they may be worth scanning later in case some open up. So administrators may want to consider blocking such ports with a firewall so they appear in the filtered state. They appear in the filtered state. So what is there in this filtered state? Nmap cannot determine whether the port is open because packet filtering prevents its probes from reaching the port. The filtering could be from a dedicated firewall device, router rules, or host based firewall software. So these ports frustrate attackers because they provide so little information. Sometimes they respond with ICMP error messages such as type 3 and code 3, type 3 code 3, or type 3 to your code 13, that is destination unreachable or communication administratively prohibited, like that. So but filters that simply drop probes without responding are far more common. So this forced Nmap to retry several times just in case the probes was dropped due to network congestion rather than filtering. So this sort of filtering slows scan down dramatically. So then another port type is your unfiltered port type. So in this unfiltered state means that a port is accessible, but Nmap is unable to determine whether it is open or closed. So only the acknowledgement scan, that is this is one type of scan, port scan, which is used to map firewall rules sets and classifies ports into this state. So scanning unfiltered ports with other scan types such as window scan, sign scan, or fin scan, we are going to talk about these, may help resolve whether the port is open. And finally, you are having the open or filtered. So the Nmap places ports In this state, when it is unable to determine whether a port is open or filtered. So this occurs for scan types in which open ports give no response. The lack of response could also mean that a packet filter dropped the probe or any response it the elicited. So Nmap does not know for sure whether the port is open or being filtered. Suppose the UDP, Internet IP Protocol, or FIN, null, or Christmas tree scans classify ports this way. And another one is the final one is closed or filtered port state. So this state is used when Nmap is unable to determine whether a port is closed or filtered. So it is only used for the IP ID, which is ideal scan, the ideal scan path. So while Nmap attempts to produce accurate results, keep in mind that all of its insights are based on packets returned by the target mission. So such host may be untrustworthy and send responses intended to confuse or mislead Nmap tool. Right? So why the scan ports means the port scanning is not only performed for fun and amusement. There are numerous practical benefits to regularly scanning your networks. So, foremost among these is security. So, one of the central tenets of network security is that reducing the number and complexity of services offered reduce the opportunity for attackers to break in. So, most remote network compromises come from exploiting a server application listening on a TCP or UDP port. TCP or UDP port. So, to check whether the port state is open, closed, or filtered or unfiltered, it uses the Nmap, use the let me just erase this. Okay, the Nmap use the TCP flags for scan, which we have seen in the previous lecture. So that is here for full connect the TCP flag, the flag bits which are used is for full connect. Okay. For full connect, the flag bit is set to 0 and send that sign packet to the destination side. If the destination side port is open, then if the destination is ready, the target is ready to communicate with the pen tester, then they will send the response or reply as sign ACK. If the port is closed, then the RST reply will be our response will be given. So your Nmap, by looking at this RST reply from the target, and it assumes that the port is closed. Okay, so this is in full connect. That means the TCP connection establishment. We have seen that there are three steps in three handshaking process. So what happens here in this three handshaking process? Full connection is validated. So after that, if any activities are going on target side, that will be recorded in the log file on target side, so that there is a chance of leaving fingerprints on target side. So instead of that, some use the sign stealthy or scan, half port scan. So in the half port scan, the connection is not fully established. So connection never established completely. So when connection is not established, then what is the activities cannot be recorded on the target side, who are scanning or not, their ports, whether their ports are scanning or not is not noticed sometimes. So for that, in stealthy scan, when this the flag bit sign is set to 0, and it will get the acknowledgement, that sign acknowledgement, and for open ports and for closed port it get the RST. And in FinScan, the fin bit, the finishing bit in the what you call the control bit is set to 1, and if it is open port, then the rest, I mean, target machine sends nothing in response, that is none. And if it is closed port, then it will reply with the RST. If there is a null scan, then all the control bits are set to 0. Sorry, all the control bits are set to 1. So that is none is disabled. So then if it is an open port, then you will get the reply none. And if it is a closed port, then the RST reply will be there. So by observing this none or RST, Nmap understands that it is none means the port is open, and RST means the port is closed. So similarly for Christmas tree, your fin bits, arc bits, and your push bits, these the control bits are set for the scanning. And by setting this, your Nmap get the response. If the port is open, get the response as none, and if it is closed port, it get the response as RST. Respond as RST. So this is the open port and closed port one, and how they are going to be work. Okay. So next we'll try to talk about the basic scanning. Okay, the Nmap basic scanning for multiple targets. If there are multiple targets are there, then multiple IP addresses are required. So to scan the multiple targets port, it uses multiple IP address. For that, it uses the subnet. That subnet is, it uses the network address. So here 1 dot, for example, 1.2.3.4 by 24 means, so it use the all these networks, means the first 3 bytes are used to scan the host. The last byte, as we know, that used to identify any host. That means if we give this subnet as 1.2.3.4 by 24 means, on this particular network 1.2.3 network, whatever number of hosts are there, all those number of hosts will be scanned. All those hosts will be scanned. So like that, your pen tester, suppose trying to scan the multiple hosts on a company's systems, if all those systems are having the multiple IP addresses, then your pen tester sends the signed request packet to your destination to check whether port number 67 on this particular target machine is open or not, to check their status. Like on another system, port number 53 is status, and another for another system, port number 25 service is open or not. So all this, to check it out, there is IP address and port number is required. So the first step, as we said, in the scanning process, needs to identify whether the host are what you call the live or not. So that is the host discovery process. So what is the command? Just type the command nmap in the terminal, Kali Linux terminal, and give the target's IP address by providing the 24 as the subnet. So then all the hosts in that network are going to be pinged, and whether they are live or not. If the pen tester get any response, that means that target is live, or else the target is down. The target is down. Or you can use this number also, scan only those targets by giving this number, that minus SN. Okay, so that means we, and suppose this host discovery can be done in two ways. So Nmap can run as a administrative privileged mode or in a local privileged mode. If it runs in administrative privileged mode, means the root privileged mode, because the UDP services will not be run using your local user privileges. So Nmap must run as a administrative privilege. So, in root privileged one, for the host discovery, the packets will send the ICMP echo request packets, and on the port number zeros, or port number 80. So our TCP sign, the sign, what you call the control bit is set to 1 and send it to the port number 445 443, and TCP ACK send on port number 80, and ICMP timestamp request. So these are four packets will be run when the Nmap scanning done through the root privilege. If through the local privilege, means in root privilege it gives the raw packets, whereas your local privilege, the packets will go, send the packets of your sign packets on port number 443 and ACK packets on port number 803, right? And without host the discovery, without a host discovery, because doing a host discovery and then finding which ports are open, which ports are closed, which ports are filtered, it takes much time. So instead of that, if you are an internal user and you know that your systems, which systems are active and which systems are not active, in that case, without going for a host discovery, directly go for your the what you call the, I mean, scanning the ports directly. So for that, the command which gives that nmap followed by minus pn. So minus pn says that don't do any ping scan. So in this case, here we use that minus n means no need to scan, don't scan any ports, just ping to these host whether they are reachable or not. That is the meaning of switch minus n minus s minus n. So here, by giving the switch minus pn, it tells the nmap that don't go for the discovery phase to check whether the hosts are live or not live. Okay, so this is the host discovery phase, and uh, in the next session we'll try to talk about the how this scanning works.